Hi everybody. I wanted to discuss a couple of things that we talked about in class today with graphs and understanding these graphs of proportional relationships. So the first thing about this graph that we did in class, I can tell it's a proportional relationship because two reasons. One, it starts at the origin. That has to be true for me to have a graph of a proportional relationship. It must start at the origin. And the second thing, it must be a straight line. It has to be a perfectly straight line. So if I see both of those things, then I know my graph shows a proportional relationship. So here it is starting at the origin, and it's a perfectly straight line. So tomorrow, when you're given a graph, or you make a graph, and you're asked, is it a proportional relationship? You have to say yes because it starts at the origin and it's a straight line. You have to say both of them. If neither one of those is true, you can say no, it doesn't start at the origin, or no, it's not a straight line. But if the answer is yes, make sure you say both. It starts at the origin and it's a straight line. So next, you're given this graph and you've got to find the unit rate. Well, remember, the unit rate is always a comparison of one quantity to one unit of the other quantity. So in this case, we want where x equals 1. So in this case, we want to know the number of beats, heartbeats, for every 1 second. So it's going to be this point right here. And I could guess what that is on the y-axis, but instead of guessing, what you should do is use any of the points that you know for sure. Use any of them. Like I could take 15 heartbeats here and 10 seconds. So I'm looking at this point right here. I can see that it's on the 15 line for heartbeats and the 10-second line for time, 10 seconds. So I know that's 15 beats. And I'm writing with a mouse here, so don't make fun of my handwriting. 10 seconds. I know that is a ratio, that is a point on this graph, that is a ratio that will be equivalent to my unit rate. So now I can use that to find the unit rate. I could take 15 and divide by 10, and I would get 1.5. Or I could solve with cross products. 15 times 1 and then divide by 10 and I will get 1.5. Or I could see that taking 10 and dividing by 10 will give me 1, so 15 divided by 10 gives me 1.5. No matter how I do it, I know that this point is 1 second, because x always comes first, 1.5 beats. So that's a key here. Finding the unit rate. Use one of the points that you know for sure. And then find that unit rate. So the other part. I ask you if 30, on the bottom here, part D, I ask you if 30 and 20 could be on this line that we're graphing here, if it extended. So that 30, what you got to understand is first of all the meaning of the 30. In an ordered pair, x is always first, and then y. So in this case, that 30 means 30 seconds, and 20 beats. So what we're asking here is 30 seconds and 20 beats. Is that equivalent to our unit rate that we know now? Or is it equivalent to any of these other points on the graph that we've created? So I've got a test. Is 30 seconds and 20 beats, does that hold the same relationship here of 1.5 beats for every 1 second? And I can see that no, it doesn't. If I have 30 seconds, I need to have 1.5 times that. I'm writing times 1.5, but I'm running out of room. I know that the number of beats is 1.5 times the number of seconds. So 30 times 1.5 is not 20. 30 times 1.5 is actually 45. So that means the answer to part D is no. 30 seconds and 20 beats would not be on this graph. So that's pretty much what you need to understand about unit rates and how to test if a point can be on the graph of a proportional relationship. So thanks for watching. Good luck tomorrow.